Okay, the first method that we are looking at is possibility trees. So we want to be able to build a possibility tree and then find all the possible answers. So let's look at example 1. So here we go. In some competitions between two players or teams, the first to win 3 games, I'm looking right here, 3 games wins the competition. So describe the possible outcomes of such a competition as a succession of steps. All right? So what we want to do is we want to make a possibility tree. So what we have to do is we're going to call the players A and B. Right? Call the players A and B. And then we're going to make a tree. So here is the tree. Okay? So, whoops. I'm in the wrong place. Let's get rid of this arrow and this thing. There we go. Now we're able to look. Ta-da! Okay. So here we go. When I start the tree right here. So this is the first dot. So it looks like a tree, right? Then it has a branch that goes up to A and a branch that goes down to B. Because we don't know who wins game 1, right? So it's either A or B. So that's easy. We got it, right? So then when we make our tree, we have to continue and we go to game 2, right? So what could possibly happen? Well, A could win game 2, and now A's won 2 in a row. Or B could win game 2, right? If A won game 2, then A has 2 in a row. That'd be 1, 2, 3. All right, 1, 2, right? But if B wins the second game, then they both won 1. Right? That's the way it works. They both won 1. But down here, B has won 2 in a row, because this is the first one and that's the second one. But if A wins here, then here they've only won 1 each. Right? So they have to play again. Have to play again. So I go here to game 3. Now look what happens. Game 3, if A wins game 3, on this row here, he's got 1, 2, 3. He's the winner, right? Because all you have to do is win 3 games. But if B wins, so A's 1, 2, and if B wins the third game, they have to play again, right? And the same thing here. A wins the first game, B wins the second game, and then A wins, right, the third game. Well, now A has got 2, but you need 3 to win, so they have to play again. And the same thing down here, B's got 2, right? And at the very bottom, B won 3 in a row, right? So B's the winner, right? 3 in a row, but here, 2 B's and 1 A. Right? Play again. So if I play it again, the winner of game 4, now I've got 2 A's, and then B wins. I'm at the very top. 2 A's, and then B wins, and then if A wins again, that's 3. That's the third one, right? 1, 2, and then B wins, then 3. And then if B wins, right, now there's 2 and 2. Because I've got 2 B's on this row and 2 A's on that row. So you have to play again. And then when you finally end, this is what it looks like. So I can get, I'm counting these as I go down here. So there's 20 when I'm done, right? 20 when I'm done. And B wins half the time, and A wins half the time. So there's 10 ways that A could win, right? B could be first, then A could win the second game, A could win the third game, and then A could win the fourth game, and he's the winner, right? Even though B won the first game. But it could also happen that B wins the first game, A wins the second game, B wins the third game, A wins the fourth game, B wins the fifth game, and then they're the winner. So it's what we're doing is we're showing how many ways there are, and so you just count the number of winners there are. Whenever there's 3 letters that are the same, they don't have to be in a row. It doesn't have to be A. It can be A, B, A, B, A. And then A wins, right? That's the deal. So that's a possibility tree, and that's what we are looking for when we make a tree. That's it.